I talked about earlier on that the language we use in this chapter sort of carries some weight in the direction of there being a cause and effect relationship between the data sets. That when we call something the independent variable and something else the dependent variable, it implies that whatever we call the dependent variable is, in a sense, the result of the independent. That a country's GDP going up will result in their CO2 emissions going up. And sometimes that is the case. Sometimes there is that connection of cause and effect, but we should be careful to understand that that connection is not required, does not always happen, and sometimes is a lot more complex than it maybe looks based on simply the value of R, based on simply what we've seen in terms of this section and what we'll get in later sections from this chapter. Now I'll say that for this stuff here, it's very important you have some understanding of it, but it's a little bit harder for me to test on than other things in here. So you're not going to see it quite as much on the homework or on the exams or quizzes or any of that stuff, but it is worth being aware of. In some sense, it's more worth being aware of than a lot of the computations we've seen here, but I'll talk about that more later. The main thing that I want you guys to finish this section with, it's so important to put at the very end, is the phrase correlation does not imply causation. That is, just because we have a significant positive or negative correlation, it doesn't mean that one thing directly resulted in the other. Because you get some pretty strange examples. Ones like CO2 and GDP, those make some sense, but there's also funkier things out there, like the idea that as the number of pirates goes down, the average global temperature goes up, or that as we import more lemons from Mexico, the amount of traffic fatalities goes down. So does that mean that as we remove pirates, we're causing global warming? Doesn't really seem quite right to me. I don't know how you feel about that. Maybe you've got a different opinion, but I don't know. It doesn't quite click. And so it's important to understand here that just because you have that correlation relationship doesn't mean that there is that type of connection. Sometimes when we're looking at these things, we actually have the relationship backwards. We're looking at one affecting the other when really we should be looking in the other direction. For another example, we might think about hearing loss and use of earbuds. That it makes sense to think that as you use earbuds more often, your hearing will get worse. Whereas on the other hand, it doesn't make quite as much sense, although it still makes a little, to think that as your hearing gets worse, you might use earbuds more, but the other direction is the more logical one. And on the other hand, sometimes we get things that are truly just random chance, like with the lemons. I don't think it's reasonable to assume that Mexican lemon truck drivers in particular are so safe that as a result, everyone else can do nothing but drive safer. It's probably just a coincidence. And then, further still, sometimes when we have these relationships and when we have these connections, sure, there is a direct link between the two, but that direct link might actually be the result of something else entirely happening. That when we're talking about those pirates, as a result of there being more options for travel, not just through sailboats, but through motorized boats, cruises, and also planes, there'd be less of a market for there to be pirates.
No! Not good! No! Not good!
And for that matter, as we've had all of those things as well, we've also had more patrols out on the oceans that are able to catch and stop pirates, so it's harder to live a pirate's life, as it were, because they didn't have quite as much of a navy presence way back when they were sailing the high seas. But in any of those cases, it's important to understand that the relationship we see in correlation isn't one that necessarily tells us why something happens. It just represents that something did. Just because two things went together doesn't necessarily mean that one brought the other. They're just both there. And I'll say that it's pretty important that you understand this, or at least are aware of it. It's the sort of thing you could make a whole class out of, or at the very least a good section of a class out of in this critical thinking exercise. But realistically, looking at things like R, a lot of you aren't going to keep working with stats. And I'd like to pretend that months, years down the line, you'll still have very positive, fond memories of this class, and you'll be able to pull out those formulas at the drop of a hat because you loved it so much. But when the stats teach you, you kind of have to pretend that that'll happen, and I know it's going to. And for that matter, those of you that are going to go on with stats are, well, you're going to learn that there's more advanced things you can do than linear correlation. There are more complex relationships with more complex models to fit them. And as a result, knowing R, knowing the types of hypothesis tests we did in this section, and the types of things with linear correlation and regression we'll see later, maybe it's not quite as useful. You want other tools to work with. And this one's more of a springboard than the thing you're going to be spending your whole life on. So, having that computation, not the most vital thing in the world, but being aware of this piece of information, that's something that you will actually use when you're reading the news or talking to your friends about studies they may have heard on the news, to understand that just because things happen that appear to be correlated, it doesn't mean that one caused the other. Anyway, that's all we're going to look at for this section for this week. We're going to finish things off next week with a look at how we can more thoroughly describe these connections with a thing called regression, and what sort of pieces might be missing from a regression model, looking at variation within it. Those are problems for next week. I'll see you in there.